Hello and welcome to helpyourmath.com. In this video, we are going to look at examples of sums and differences of polynomials. We're going to start off with a little review. First, the definition of a polynomial. A polynomial is an expression in which every variable present has a positive integer exponent. And we're going to focus on the monomials of each polynomial. A monomial, that's a polynomial that contains one term. If two monomials are identical except for their coefficients, then they are like terms. We can combine like terms by adding or subtracting the coefficients depending on the signs. When we do this, the rest of the term does not change. So there's a little bit of vocabulary to unpack here. First of all, the coefficient. So monomial could look something like 4m squared. This would be a monomial because it's just that one single term. There's no plus or minus signs. Or if there was a plus sign, we would say this is one of the monomials, and then whatever's on the other side of the plus sign is another monomial. The other thing I called out here was a coefficient. So a coefficient is the number in front of a term when it's being multiplied to other things, whether it's variables or radicals or fractions. So this would be the coefficient of this particular monomial. If we had a monomial that was just a single number, like if we just had a half, this isn't called a coefficient because it's not being multiplied to anything else. We would call this a constant. Okay, so these are some terms that do come up as we go through polynomials and expressions in general, so they're kind of handy to know. And then what I'm talking about here, when I say we can combine by adding or subtracting the coefficients, if I had 4m squared, and then I had another monomial, let's say 7m squared. These two terms, these two monomials are identical except for the coefficients, right? They both contain the m squared and nothing else. So we could combine these. I have 4 of these m squareds here. I have 7 here. We combine by adding the coefficients 4 plus 7. But otherwise, the rest of that term will stay the same. And then we would say that we have 11m squared. And when we do get to subtraction, we want to keep in mind the rule of subtraction. That is, we can rewrite it as addition by adding the opposite. So we might have seen this when we were looking at integers. If we have 4 minus negative 7, we can rewrite this as 4 plus positive 7. So it's whatever's behind the subtraction, we rewrite as addition, and then we just follow the rules of addition. Now I have positive 4 plus positive 7, which will be positive 11. When we have a polynomial behind the subtraction sign, the entire polynomial is being subtracted, so we will need to distribute the subtraction sign. First, we're going to start with adding, and then we're going to review that adding the opposite when we get to subtraction. Again, when we add polynomials, we look for the like terms. We can either add these vertically, where we line them up by like term, or we can just go horizontally. When I do that, I like to underline, or since I'm at a computer, I can highlight and make it really nice and very clear as to what's being combined. I'm going to do the first example vertically just because I think it is an interesting approach, although sometimes it does create more work for us. So what I'm going to do is I'm going to say this is the sum. So we're adding these two things because this keyword means add, or the answer to addition. And then what I'm going to do is I'm going to take this second trinomial and I'm just going to line it up underneath. So it's plus 5x squared minus x and minus 14. When it says to add, that doesn't mean we change any signs. We just combine them as they are. And now I work straight down. So these are like terms. We have minus 8x squared and 5x squared. Negative 8 plus 5 is negative 3. And then we keep the x squared the same. In the middle, I have 3x, that's a positive 3x because there's a plus sign in front of it, and a negative 1x, right? There's that invisible factor of 1. I have 3, I'm taking away 1, that leaves me with positive 2x. And then lastly, I have minus 9 and minus 14. My constants are both negative. We're going to combine them and keep that negative sign. 9 and 14 make 23. And this would be our sum, which also ends up being a trinomial. How lovely. So far, so good. Let's move on. In this next one, we have a trinomial 10y cubed minus 4y squared plus 11 is the first trinomial, being added to the second trinomial 8y cubed minus 5y minus 2. The other thing you might notice that I do is I always start with the term that contains the largest exponent. So I notice that we do have a y cubed. I want to start by combining all my y cubes. Then I look at my squares, then my invisible 1 exponents, and then my constants last. And I'll always do that no matter what the largest exponent is. Okay, I'm going to keep these horizontal. I'm going to use my highlighter and I'm going to say 10y cubed is like terms with 8y cubed. And when we go to add 10y cubed and 8y cubed, they're both positive, and 10 plus 8 is 18, so we have 18 y cubes. Next up, I'm going to look at my y squareds. I have this minus 4y squared. I don't see any other y squared, so minus 4y squared doesn't have any like terms. We're simply going to move it over to the sum. So I'll say minus 4y squared. Next up, I'm looking for my y with an invisible 1 exponent. I have this term over here, minus 5y. It has no like terms, so just like the minus 4y squared, I'm just going to write minus 5y in my final sum. And lastly, the constants, I have a plus 11 and a minus 2. Plus 11 and minus 2, oh sorry, that purple is really dark, but plus 11 and minus 2 make positive 9. So I added a trinomial and a trinomial, and I ended up with a polynomial with 4 terms. That's fine because, we have to follow the like terms. We don't get to decide, no, this should be a trinomial. That's not totally how this works. So we ended up with 4 terms, but none of them are like terms. In this last example of adding polynomials, this time we have 4 binomials that want to be combined. I'm going to start, largest exponent I see is 2. So I'm going to start with all the n squareds. 4n squared, nope. Minus 5n squared and 6n squared. When I go to combine these, again, I focus on the coefficients. I have 4, negative 5, and 6. I'm going to start by adding my positives. 4 and 6 make 10. And then 10 minus 5 makes 5. So it would be 5n squared. Next up, I'm going to look for just terms that contain an n with an invisible 1 exponent. There's an n, a minus n there, and there's a minus 4n there. When I combine a minus 1n, right, not only does that have an invisible 1 exponent, it also has an invisible 1 coefficient. So we have minus 1n and minus 4n. They're both negative, and they're going to combine to make minus 5n. And then lastly, our constants, we have a plus 6, a plus 3, and a minus 7. I always like to start by combining the things that have the same sign. So I'm going to combine that positive 6 and positive 3 and get positive 9. And then 9 minus 7 would be a positive 2. And there we go. I combined 4 binomials and I ended up with a trinomial. This was adding polynomials. Let's take a look at subtracting polynomials. As I mentioned earlier, when we subtract, we could rewrite it as addition by adding the opposite. When we have a parenthesis behind the subtraction, we change all of the signs of everything inside that second polynomial. It's similar to distributing a negative 1. Anything that's behind it inside the parentheses will change the sign. So starting with this question 4, we want to subtract this first trinomial by this second trinomial. I strongly suggest change the signs. So what I'm going to do is I'm going to distribute the subtraction. This positive 4x squared becomes a minus. I distribute the minus to the minus. Remember, a minus becomes a positive. And again, a minus becomes a positive. Once I've changed the signs, I've fulfilled the operation that is subtraction, and it becomes addition. Once we have the addition, now we can do just like we did on the previous slide. We can start looking for like terms. I have a minus 7x squared and now a newly minted minus 4x squared. When I go to combine those, they both have negative coefficients. Negative 7 and negative 4 make negative 11 of these x squareds. Next up, I have minus 9x and positive 10x. When I combine negative 9 and positive 10, I get positive 1. I don't need to write the 1. I can just write x. And then lastly, my constants, I have a plus 3 and a plus 2. Plus 3 and plus 2 make plus 5. So when I subtract these trinomials, one from the other, I end up with negative 11x squared plus x plus 5. How about question 5? So question 5 says subtract this thing from this thing. So that means the 8g cubed plus 3g squared minus 7g, that's the one that's being subtracted. So that's behind the subtraction. So when we go to set this up, what I can do is I can just rewrite it so that it's over here and say minus, And I keep this trinomial inside parentheses because the entire trinomial is being subtracted. And now I want to distribute the subtraction sign. So again, that's going to change the signs. This positive 8g cubed becomes negative. This positive 3g squared becomes negative. This minus negative 7g becomes plus. Then once I've changed the three signs, this becomes a plus. And now I'm going to start looking for like terms. I have 12g cubed and negative 8g cubed. That's going to combine positive 12 and negative 8 make. That's going to combine positive 12 and negative 8 make 4g cubed. Then we have squared. I'm looking for the squared. There it is. That's the only one. So I would just say, and I'm just going to rewrite that plus negative as minus 3g squared. Clean it up a little bit. Then I have, let's see, a minus 3g and a positive 7g are like terms. Minus 3 and positive 7 make positive 4g. And last but not least, I have this minus 17. And since it's the only constant, we would just say minus 17 at the end. And this would be our final difference. So when we subtract things, we can say that the answer is the difference. The difference between those polynomials is 4g cubed minus 3g squared plus 4g minus 17. All right, question 6, last question of this video. We've got a whole mess of things going on here. Let's start with the subtraction. So the subtraction is right in front of that binomial. We're going to change the signs of the binomial, of the terms inside the binomial. This positive 3x becomes a negative. This positive 6 becomes a negative. I have fulfilled the subtraction, so I change it to addition. Next, I'm going to look for like terms. I see the largest exponent is a square. So I have 5x squared here, 2x squared here. I go to add those and I get 7x squared. Then I have a minus 6x, a minus 3x, and a positive 9x. When I go to combine those, so I'm going to combine my negatives because I like combining the same signs first. Negative 6 and negative 3 make negative 9. So I have negative 9x and positive 9x. And so what happens is I don't have a term that contains an x because these add up and make 0x, which is just 0. Because I have other terms, I don't need to include a term of 0. There just is no x term in our final difference. And last up, our constants, we have plus 4, minus 6, and minus 8. You know me, I want to start with those minuses because there's two of them. Minus 6 and minus 8 make minus 14 or negative 14. And negative 14 plus 4 makes minus 10. So when we subtracted these, when we combined these, because there was addition and subtraction, we ended up with a final result of 7x squared minus 10. These have been examples of adding and subtracting polynomials. Thank you for stopping by.